Hi 6th graders, this video is on rates and ratios proportions, so make sure you find the notes template that you were given with the notes that go along with this video, and if you don't have them you can find them in today's folder and you can print them off, or you could try to split screen, or you can just not use the template and write down in your notebook like usual. So a proportion is an equation that states two ratios are equivalent. They have a constant rate or ratio. So a proportion is, here's an example of a proportion right here. 1/2 equals 3/6. So you can see that there's two ratios and they are equal. We know that 1/2 and 3/6 are the same. We also can see 8 feet over 10 seconds to 4 feet over 5 seconds are the same because 8/10 and 4/5 are also the same. So an equation that states two ratios are equivalent. One way that we can determine if two ratios make a proportion, meaning that they are equivalent, is that we can use cross products. And what we can do is we can multiply the diagonals by each other. So we would have 1 times 6 and then 2 times 3, and we check to make sure that they are the same, which they are. 6 equals 6, so therefore this is a proportion because the cross products are equal. So how can we use ratios to set up proportions? A baker can make 25 cakes in 4 days. At that rate, it would take 12 days for him to make 75 cakes. Set up the proportion for this situation. So it doesn't matter if we have cakes over days or days over cakes. It matters that these go together in one ratio, and then these, the 12 and the 75, go together in one ratio. And then we also have to make sure that we have either both have days on the top or both have cakes on the top. So let's do 25 cakes in 4 days equals 75 cakes in 12 days. So notice that we have 25 and 4 go together right here, and then 75 and 12 go together, which is these right here. And then we have cakes to cakes on the top, days to days. So that's how we set up our proportion. Now to determine that they are a proportion and that they're equal, remember we would just take our diagonals. So we would do 25 times 12, which is 300. And then 75 times 4, which is also 300. So I know that 25 times 12 is the same as 4 times 75 because 300 equals 300. During the last storm, 22 inches of snow fell in 7 hours. At this rate, in 17.5 hours, 55 inches of snow would have fallen. So we are going to do 22 inches in 7 hours equals 55 inches in 17.5 hours. So notice we have the 22 and the 7 together here, and then the 55 and the 17.5 here. Inches are both on top, hours are both on the bottom. So it's very important how you set it up. Then we would do 22 times 17.5. Oops, that should be a multiplication sign, which is, 385, and then it would be the same as 55 times 7. 55 times 7 is 385, so then they are proportionate. We are going to skip this problem and do this problem in class. You pause the video and try these two and then come back and check your work. Okay, so if we have 60 voted out of 100 registered and 84 voted out of 140 registered, we can set it up by 60 voted over 100 registered equals 84 voted to 140 registered. And then we check to determine if they are proportional. So 60 times 140. And then 100 times 84, and they both are going to equal 8,400. which means yes, they are proportionate. So you should have set up your proportion like this and then checked it like this. All this work. And then we have 16 yards for $12 is the same as 24 yards for $9. If you flipped it around, that's fine. You'll still get the same proportion because you would get 16 times 9 is 144, and then 24 times 12 is also 144, so they are proportionate. So now we're given a proportion, but we have to find a missing value to make the equation proportional. So let's look at this one right here. 21/5 equals C over 7. So we need to figure out what can we put in for C to make this a proportion. So remember what we do is we multiply our diagonals. So we would do 21 times 7, and then we would do this diagonal, which would be 5 times C. Well, 21 times 7 is 147, and then we have 5C, or 5 times C. So I know that 5 times something, because remember this means multiplication, 5 times something equals 147. So I could go backwards and I can do 147 divided by 5 equals C. So 147 divided by 5 is 29 4/10, which means that C equals 29 4/10. And then we would check it, and I can do 5 times 29.4, and I would get 147, which would equal the 21 times 7. Then we'll circle our answer. 2 6/10 over 13 equals 8 over n. So we would do 2 6/10 times n equals 13 times 8. 2.6n equals 104. And then what I'm going to do is I'm going to take 104, divide it by 2.6, because 2.6 times something equals 104. So 104 divided by 2.6 equals 40. So n equals 40. And then I can check, and I can do 2.6 times 40, and it should equal 104. So before you pause and try these, I want to show you one more time. So if we look at 16 over k equals 2 over 3, really what I'm doing is I'm finding the diagonal, which has the two numbers, so not the diagonal with the variable. So I would do 16 times 3, and then I'm going to divide it by the last number. So I would do 16 times 3, which is 48, divided by 2, so then k would be 24. Let's look at this next one before you do the last one on your own. So 2 over 6 equals 5 over 8. So I find the diagonal with just the numbers, which would be 6 times 5, and then I'm going to divide it by 2. Because this diagonal has the variable, so I'm looking at this one first. So I multiply the two numbers that are diagonal from each other, divide it by the third. 6 times 5 is 30, divided by 2 equals 15. So h equals 15. And then we're going to check it, which I should have done on the last one. And let's erase this so we can actually see the problem. So we know that 2h, so 2 times 15 equals 6 times 5. 2 times 5 is 30 equals 30, so then it checks, and then we circle our answer. You do this last one, come back and check. So I would do 10 times 4, divide it by 2.5. 10 times 4 is 40, divided by 2.5. 40 divided by 2.5 is 16, so k equals 16, and then you would check it. 16 times 2.5 equals 10 times 4, and it would be 40 equals 40, so it checks. For every 18 people who have a sore throat, there are 2 people who actually have strep throat. If 72 patients have sore throats, how many of these would you expect to have strep throat? So 18 and 2 go together. So 18 sore throats go with 2 strep throats. And then we're given if 72 patients have sore throats, so that means I'm going to put the 72 on top because these are both sore and then these are strep. So we want to figure out how many would you expect to have strep throat, so that's going to be my variable. So we've set up a proportion, now we solve. 2 times 72, because this is my diagonal with the variables, so 72 times 2, and then divide it by 18. So we have 72 times 2, which is 144, divide it by 18, and we get 8. So we would expect to have 8 people have strep throat if 72 patients have sore throats. And we want to make sure that that makes sense. Well, I know that about 1/9 or 1/9 of 18 is 2. And so this one, so if I look at 72 and I think, is 8 1/9 or is 8 around 1/9, then that would make sense. If my answer was all of a sudden bigger than 72, but here it's telling me that the people with strep throat is smaller than sore throats, then I would know my answer didn't make sense. Salvador can run 120 meters in 24 seconds. At this rate, how many seconds will it take him to run a 300-meter race? So 120 meters over 24 seconds, because those go together in one ratio. How many seconds will it take him to run a 300-meter race? We're given 300, which goes with the meters. So we want to find out how many seconds. If you want to pause and try to solve this on your own, you would do 300 times 24, because I take my diagonal with the 2 numbers. 300 times 24, divide it by that last number. So we would do 300 times 24 is 7,200, divide it by 120, and I get 60. So it would take him 60 seconds to run 300 meters. And then lastly, you try these in your notebook and then on the notes template that you have in front of you, and then we'll go over them in class tomorrow. And that's all I have. Thanks for watching. Don't forget to have your notes in class. Have a great day.